Welcome to part 2 of the wind calculation module. This video tutorial will demonstrate on how to use RCB wind spreadsheet for wind load calculation. Applicable codes, NSCP 2015 and ASCE 7-10. Step-by-step manual calculation for wind loads are covered on part 1 of this module. We will use the same example as that in part 1. We have here a steel warehouse with dimensions as shown. Basic parameters have already been defined. Wind speed is 310 km per hour or 86.11 meters per second. Directionality factor is 0.85. Exposure category is C. Topographic factor equal 1.0. Gust effect factor equal 0.85. Enclosure classification is enclosed building. Internal pressure coefficient is plus and minus 0.18. Now using the RCB wind spreadsheet, click on the Modify Inputs button to change the parameters. Set the wind velocity to 310 km per hour. The program provides the 3 wind contour maps as provided by the code. You can view these maps by clicking on the Help button just beside the velocity input box. You may zoom in the maps to view the wind contour values clearly. Select Exposure Category C in the drop-down menu. Enclosure classification is enclosed building. Directionality factor equals 0.85. Topographic factor equals 1. Under the Building System option, select Moment Resisting Frame Steel. Our building type is gable roof. Let's also set the building dimensions. Building width is 36 meters, building length is 60 meters, eave height is 6 meters, and height to apex is 10 meters. If you need help for this inputs, you may click on the Configuration button. Since we don't have any parapet or overhang, we leave the Include Parapet or Overhang option unchecked. Now for building natural frequencies, if you have a mathematical model just like in ATABS, you may just run a modal analysis and get the natural frequencies of the modes normal and parallel to the ridge. This is a more realistic way of considering building flexibility. But if you don't have these values, you may just leave it blank and the program will automatically calculate the building natural frequencies, according to the approximation provided by the code. For now, let the program calculate these values for us. For the gust effect factor, we set the value to 0.85. This value was used since we've considered our building as rigid as discussed in part 1 of this module. Now that all the parameters were defined, we can click OK to save this input. Click on Run Analysis button to perform the calculation. Now that the analysis is complete, we can already see the wind load action in the building surfaces. This is much faster than doing a manual calculation and going through several tables in the code. We can navigate the wind load direction using these arrows here. Wind direction due north, wind due west, wind due south, and wind due east. To change between load cases, we can select the case number in the load case drop-down menu. We can see here 4 available load case. Meaning, we have 4 load case for wind direction 0 degrees or due east. Let's look at case 2, case 3, and case 4. Taking a closer look in case 1 for wind normal to ridge. We can see here a pressure of 1.697 kPa for windward wall, negative 2.232 kPa for leeward wall, and negative 2.86 kPa for side walls. For roofs, we have negative 2.543 kPa for windward roof, and negative 1.922 kPa for leeward roof. These values are the same as the values we get using manual calculation in part 1 of this module. For wind parallel to building ridgeline and selecting case 1, we have 1.966 maximum wind pressure in the windward wall, negative 1.814 kPa for leeward wall, and negative 2.86 kPa for side walls. For roofs, negative 3.49 kPa for ranges 0 to H, negative 2.32 for H to 2H, and negative 1.61 for greater than 2H. Values are also the same as the values we get using manual calculation. You may rotate the view to have a clearer visualization of the loads. You can also switch between views. And of course, for the detailed calculation, we can click on the Display Calculation button. Scroll down the page to inspect the detailed calculation. We can also export this calculation as MS Word document. In the third part of this module, we will be applying these load in a mathematical model. We will be using the program ATABS as an example. That concludes this tutorial in using RCB Wind Spreadsheet. Thanks for watching.